Functions Notes, Part 2, Section 10C, Different Notations with Domain and Range. So here's a picture. And looking at the picture, we can see that the x's don't start until -1. So we could say the domain is all x greater than or equal to -1, because this point is -1 and it spits out a -3. And then maybe at this point, maybe this is 2. I don't know, but maybe this is 2. It spits out there 3, 4. Any x, all of these points will have some x and some y, but those x's won't be any smaller than -1. Okay, for the range, in this case, the lowest it is -3, and then notice it's heading up. So my range is y is greater than or equal to -3. So that's kind of the standard notation, but in your secondary classes you may have seen interval notation, which is what IB likes. So interval notation would say we're starting at -1, okay, and to get this equal to symbol we'd use the closed bracket, so we're starting at -1, and we're doing all numbers up to infinity, and since you can't ever touch infinity, it is a open bracket. For the range, again, we're starting at -3 and we're heading up. So it is from, we do touch -3, and it goes up to infinity. The next one is a quadratic. And we're going to look for any quadratics that are vertical like this. They open up or down. Your domain is always going to be -infinity to infinity, or x can be any real number, is an element of any real numbers. We'd write that as -infinity to infinity. And that is because even though it's going down, it's forever heading to the left and forever heading to the right. So if I wanted to put in -20x, I'd just be some point down here on the picture. So any x would work. The problem comes in this case with the y's, because it goes down forever, but it stops when it gets to 1. So we would say y has to be less than or equal to 1. And then for the interval notation, we always start with the smallest number, so it's going down forever. So we're going to say from -infinity up to 1. Those are the y's that the machine will spit out no matter what x you plug in. Lastly, for this one, okay, this is a interesting function. It has an asymptote at x equals 2, which means the graph will get closer and closer and closer and closer and closer, but we'll never touch it. And it also has an asymptote at y equals 1, which means it'll get closer and closer and closer, but the y will never touch it. And so we have to look at it in pieces. So for the domain, notice that we're heading that direction forever. So I'm going to do interval notation first. That is from -infinity. And it keeps heading right or positive up to as close as it can get to 2. So 1.9999999999999. But it's never going to actually touch 2. It's going to skip over it. So we do a bracket. And then we're going to do a union symbol. It jumps over it. Now we're up here, but we're still a little bit after 2. And we can continue to head this direction for infinity. The other way to say that would be x is an element of the real numbers, except x cannot equal 2. That's the only number that doesn't work. If we wanted to look at our range, it's the same idea. We always start from the bottom. So starting down here, is it touching the graph? Yes, because this goes down forever. So my range is -infinity. We're heading up, even though we're heading left, we're heading up, 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 and we're going to get as close as we can to 1. Then we're going to jump over the 1. Now we're over here in the positive numbers, but that's okay. We're just looking at the y's. And we're going to go from 1, and then we can head up forever to infinity. And again, if we were going to write that, we would say y is an element of the real numbers, except for y cannot be +1. Okay, and then this vertical asymptote right here, just as a side note, we could find the equation for that. This formula is y equals some number or something divided by x minus 2. And the way I know that is the only way we plug a number in and not be able to get out a specific, have an issue is if x can't, excuse me, let me clarify. The only way we can't have an x is if it's going to make the denominator go to 0 or make a radical be negative. So in this case, x is 2 where it doesn't work. Well, the only way that would work is if the denominator was 0. So if x was 2, 2 minus 2 would be 0. So this equation, if you were to graph it, would be in this format where the denominator is x minus 2. And that's just a side note that you probably have seen before. Okay, here's some other examples. Okay, just like before, x is greater than or equal to 3. That's all numbers 3 or bigger. X is less than 2. That's 2 or less. If you wanted to write these in bracket notation, again, that would be from 3 to infinity. This one would be from negative infinity up to, but not including 2. If we wanted to say negative 2 is less than x is less than or equal to 1, and actually then we could write it in bracket notation. It looks like this. It's all the numbers negative 1.999 forever up to 1. So we don't ever touch negative 2, but we do eventually get to 1. Or we could have the or issue where x could be less than 0. So from negative infinity to 0. But we're jumping over, and then x can be 4 up to infinity. Okay, just a little side note. The next section is function notation. Okay, and so I already brought up the function machine, but think of the x value goes in, the machine works on it, and the y value comes out. Okay, f of x is the output of y for a given value of x. Okay, you're going to plug in the x from the domain and it'll spit out the y. So for example here, if x is 2, we could say y equals 2x plus 3. And one way you may have seen this is we'd say let x equal 2 and evaluate. That means we're going to put a 2 in the machine. 2 times 2 plus 3, that's 4 plus 3, or 7. So it would spit out a 7, and you'd write the answer as an ordered pair, 2, 7. And then if you wanted to graph the answer, you'd graph the pair. A new way you might have seen it, or another way you might have seen it, is f of x. This is function notation. F of x equals 2x plus 3. And we say find f of 2. It means the same thing. Put 2 into the machine. So it just means the same thing. And it would still spit out a 7. So you could say f of 2 is 7. All right. There's one more funky notation, kind of like this. F such that x goes to this expression. It won't be used, but you might see it in your book, and it's meaning the same thing. It's meaning here's our function f of x. 2x squared minus 3x, and it says find the value of f of 5. So we're going to plug in a 5. 2 times 5 squared minus 3 times 5. There was an x here, and notice what I did is everywhere there was an x, I put parentheses and plugged in my 5, and that will equal 35. And so it's really the point, if you were to graph it, 5, 35. Okay, here's another example. Okay, we're going to plug in, it says plug in f of negative x. So instead of plugging in a number, we're going to plug in this expression, negative x. So we still write our equation. We need to plug in f of negative x. And so we're going to write our equation down. And everywhere there's an x, I'm going to put a parenthesis. And then I'm going to go ahead and plug in my input, which in this case is negative x. I'm going to do that in orange. And then I'm going to simplify. So we have 5, a negative and a negative is a positive x, minus negative x squared is x squared. So the negative in here went away, but I kept this one. And it doesn't simplify anymore, so that's my answer. So f of negative x equals this. And it's basically just saying if you put in a negative number, it would come out in this form, and you could plug in any number for x. Okay, so plug in and simplify. That's for A. Part B is the same idea, but everywhere there's a parenthesis, you put in x plus 2. And then you simplify, and it's just an algebra problem. So we're going to have 5 minus x minus 2, because I'm going to distribute the negative. And then I need to FOIL this. So remember, x plus 2 times x plus 2, that's x squared plus 4x plus 4. That's still in the parentheses. Literally, I just took this part right here and FOILed it out, and then plugged it back in right here. Now we're going to keep going and combine like terms. So we have 5 minus x minus 2, distribute my negative, minus x squared minus 4x minus 4. So let's see, we have a negative x squared. I'm going to switch colors here so you can see. We have minus x and minus 4. So that's minus 5x. And 5 minus 2 is 3. Minus 4 is negative 1. So f of x plus 2 is this new equation. This last section will be on its own video.